Hello mathematicians, just a little aside on implicit differentiation. Implicit differentiation is used to differentiate implicit functions. And implicit functions have both variables on one side of the equality. So we're going to focus on implicit functions and how we actually carry out the process of differentiation without having to rearrange the equation. So have a look at this function, y equals 2x squared plus 5x. If I asked you to differentiate this, which is an explicit function because it's got y on one side, the x is on the other, then we know dy dx would equal 4x plus 5. Now, if I had my original function written like this, which is of course the same thing, I could use implicit differentiation to do this. So if I differentiated right through this equation to find, and I differentiated with respect to x, then I'm differentiating y with respect to x. I'm differentiating minus 2x squared with respect to x, which would give me 4x. I'm differentiating 5x with respect to x, which gives me that. And then, of course, rearranging dy dx equals 4x plus 5. Now that was a trivial example, so let's have a look at a slightly more complicated one. So here's our equation for a circle. Now, if I apply implicit differentiation to this, it means that I differentiate x squared with respect to x, which becomes 2x, and I differentiate y squared with respect to x. Now, that means that I have to think of y as being some function of x, and I use the function of a function rule, or the chain rule. So I differentiate y squared, which is 2y, and I multiply that by dy dx. So the rule that I'm using is that I've looked at y squared, and I've said I take d dy, and then I multiply that by dy dx. So I've taken the differential of y squared dy, multiplied that by dy dx, and I get this, which is my chain rule. And over the other side I get 0. So then I am going to get 2y dy dx equals minus 2x. So dy dx is equal to minus 2x divided by 2y, or minus x on y. So why do I actually need this process of implicit differentiation? Well, because you know that this is a circle, if I had tried to make y the subject of this, you know that I would have got y equals plus or minus the square root of 25 minus x squared, where one is the positive semicircle and the other, the minus, is the negative semicircle. So when I go to differentiate and find the slope of that circle, then I need to know, for the point that I'm interested in, whether I'm in the positive semicircle or the negative semicircle. I need to have two dy dx's. Dy dx of the positive semicircle and of the negative semicircle, and use the appropriate one. However, with this expression down here, dy dx, I don't need to know that, because it just depends on minus x over y. I take the x value, divide it by the y value at that point, and that will give me the slope. You might like to verify that for yourself by working with a circle.